Hey guys, welcome back to Rocket Gyan, my fellow space tubers. Was oh man, it was such a after such a long time we are meeting again to discuss about rockets, space, and everything. Been a hard month for me. So much going on in my life right now. So yes, and I just realized that I haven't started the. Just give me a sec, and I'll do that. In the meanwhile, guys, uh, how are you? How are you? I've been, this month was not so good for me, but I hope everything is going great in your life. And yeah, let's hope in my life also, the next month should be the best one. Let's hope that happens. Let the time. Okay, guys, yes, so we are back here to see another launch for today's for today's launch. I mean, because there have been like three launches, two from China in just a single day, and now we will be seeing one of the most exciting launch for this year, Landsat launch. Landsat program is the oldest program which NASA has been running. Like, it's been 50 years since NASA started the Landsat program, and now it is in 1972, I guess it started, and it's 2021, almost 50 years since NASA started this Landsat program, and it has provided enormous amount of data, not only data but useful data which has saved lives, help us better understand Earth and whatnot. So we'll get into everything. And yes, hi Chris, hi Louis Smith, hi Carpenter, hi Richard, hi Mr. Skull. I hope everyone is doing great. So let's get started. So this is the rocket which will be launching today, the Atlas 5401 configuration. So 401 means that the fairing will be of 4 meters, which is a smaller fairing which we can see here. And the Centaur stage is not inside that fairing. So obviously it is, not a heavy payload which it is carrying. Zero means that it will not be having any solid rocket boosters, which is evident from here. There is no solid rocket booster. And one means that the Centaur stage will be having just a single engine on. And as you know, the center upper stage is like the most efficient and the most advanced stage which is being flown in today's world. So moving on. So okay, yes, this yeah. So this is the Atlas 5400 series, which we can see here. This is a cross-sectional area, and you can see the exploded view of the rocket. The RD-180 engines, we'll talk about it in a bit. And the Atlas 5 booster with the fuel tank obviously running, carrying RP-1 and LOX. The Centaur upper stage, the RL-10 engine, and the spacecraft with the payload fairing. And you can see that these payload fairings are a bit corrugated, if that is the correct word for these type of strips here. That is because this is made up of metal, and metal, as you know, is kind of malleable, and it does have that flex in it. So to make it more stiffer, we have this corrugated things on the fairing, these stripes basically. what they do is like they take the metal and they fold it, and we have this 3D stripes on it, so make it more stiffer. Okay, this is the rocket. Now let's have a look at this engine. This is like the most advanced engines of its own time. You know, this is the Russian engine, the RD-180 engines, which runs on RP1 and locks as its fuel, and it looks beautiful when it is running, which we can see here. The engine bells are literally of white color, and yes, this is what how it looks like, the RD-180 engine. This is the derivative of RD-170 engine, which is currently the most powerful engine, the liquid fuel engine that has ever flown. The RD-170 engines were used in Energia rocket, which was like the what should I say? m- my favorite rocket for the Russian in the Russian, you can say, the rocket family, the Energia rocket. It was having that RD-170 engine. So the main thing about this engine is that it is having it seems like it is having two engines, but no, that is not the case. It is having two combustion chambers, but it is having just a single turbine. So basically it is having just one single engine, but it is having two combustion chamber. Now if you ask me why is that so, simple reason is that you need to, by having these two combustion chambers, what they are doing is they are distributing that pressure which is being which is actually coming onto that throat. And as you know, uh, most right now the most pressure which can be handled by the any engine is of Raptor, which is around 300 bar if I'm not wrong. But that was not the case back in 1970s and 80s when this was developed. So they what their Russian engineers did, they split these two split one combustion chamber into two halves, so that the pressure can be released and they can have the engine running. The main engine is basically the RD-170 engine, has four combustion chambers and one single turbine. The RD-180 is having two, so it's like a derivative of this and less powerful than that. Okay, moving on. So I just wanted you to see. I'm not explaining those things here. Just wanted you to see that this turbine here. You can see this main turbine. This is the RD-180 engine schema diagram. You can see this is just a main turbine and it is feeding both the combustion chamber here, this one and this one. So yeah, and talking about the fuel and the oxygen oxidizer, this one runs on RP1 and LOX and runs on stage combustion cycle, which means that it is having the fuel is being burnt in stages and not being burnt in just one go in like pre-burner or so, being burnt in stages, so it provides more efficient. Okay, moving on. Now let's have a talk about this beautiful satellite, and beautiful as well as a powerful satellite going to space today. This is the ninth satellite in the Landsat constellation. The Landsat 8 was launched way back in 2013, and now this is being launched. This is a Earth observation satellite, and this is carrying two instruments. One is inside this white box and the other is inside this you can say this type of box, what should I say, left side. Okay, and the sec now. Okay. Now, why am I saying it is so good to have these satellites going into space? Well, they are first of all Earth observation satellite, and they have provided enormous amount of data since 50 years. And now, since this will be launching in Landsat line, and Landsat 8 has already been launched and it is working fine, what will happen is in just 8 days they will be providing the data of whole Earth. Yes, they both will work in conjugation, what we say, that the right word, basically I want to say they both will work together to provide the data. And Landsat 8 plus Landsat 9, they both will work together, and we will have like 8 days. In 8 days we'll have the data of whole Earth, which is great when we are when we are going in the polar orbit. Okay, now talking about the instruments, this is one of the instrument which is okay. Let me have a look at for this one. So this one This instrument is what we call as OLI-2 design, which is the basically the actual camera for this satellite. This is a very powerful camera. You can see here. First of all, what happens? The Earth view baffle. This will have the light intake. This is the shutter wheel assembly. So it's like a shutter. When you don't want to use it, you can just have the shutter here. It should work fine. And inside that shutter, after the light goes inside the shutter, it passes through bunch of lenses, or you can say the sensors, which detects the light in 9 bands, which is so cool. And this solar view baffle, if you can, you know, you must be wondering, why do we have this solar view baffle? This is Earth observation set, right? We should just be having this solar the Earth view baffle. Why is there a solar view baffle? The simple answer is that the solar view baffle will be pointed towards the sun, and no, it is not being observe the sun, but will be used for the calibration of the instrument as well as the satellite with respect to the sun. So sun could be used as a star tracker, which could be used for calibration of the instrument as well as the position of the orientation of the satellite. So that is the thing. And talking about the swath, this will be having a 15-degree field of view covering around 185 kilometer of the ground swath. And yes, this will provide various band of data from blue band to infrared to invisible, almost all of the bands that are there on light spectrum. Okay, now moving on to the next camera, you can say that, not this one. Watch this video. It this one. So this one is the TIRS-2, which is the thermal, actually the thermal camera, you can say. And it is having this cryo cool radiator, the Earth view, the focal plane electronics, and black body radiation. So why do we have this cryo cooler radiator? Because literally this thing works on 43 Kelvin. This needs to be so cooled down to work at its operable temperature is at around 43 Kelvin, which is around minus 230 degrees Celsius. So this is a thermal camera, so it is a very sensitive instrument towards the thermal radiation. And what it does is it captures the thermal radiation coming out from the Earth, and it measures it so that we can have an infrared view also of the Earth. And we can detect where the temperature is high, where the temperature is low, where if there is a fires in some area, so we can detect those. So this is also a good instrument to have. Now the whatever I have said about the Landsat, let's have a look at the Landsat satellite only, and you will be amazed to see how important this satellite is. And just watch this video, you should be having the idea.
Landsat archives. Each scene is a satellite image from space, about 115 miles wide.
This is NASA's launch coverage of
Researchers and, well, just about anyone can download scenes from the Landsat archive managed by USGS. Landsat holds the title for the longest continuous space-based record of Earth in existence. That's 50 years of scenes like these, helping scientists and researchers understand how our planet is changing over time. It will take Landsat 9 and its sister satellite, Landsat 8 days to image all of Earth's land and coastal areas. That means we get a complete picture of Earth every 8 days. In this case, 2 satellites are better than 1.
It's an excellent video, basically.
Landsats 8 and 9 can work together to provide near real-time data about what's happening on the surface of our planet. Landsat collects images of each of our planet's 7 continents. Farms, forests, waterways, glaciers, urban areas, Landsat sees it all. Remember, you can't manage what you can't measure. whether it's deforestation in the Amazon, or ice loss in Antarctica, or urban sprawl in Shanghai.
Fire engine. Liftoff. Time 17:56.
We have liftoff.
Landsat 6 launched on October 5th, 1993.
Apogee kick motor should ignite right now and take Landsat to its final circular orbit.
But it never made it to orbit. NASA's team of scientists and engineers got to work immediately to figure out what went wrong. Turns out it was a rupture in the rocket fuel chamber. They used failure as an opportunity to learn. 6 years later, the team launched Landsat 7,
Liftoff of the Delta II rocket with the advanced...
one of the most technologically advanced Earth-observing satellites of its generation, still in use today. At least one Landsat satellite has been orbiting Earth since 1972. That's nearly 50 years of steadfast observation. That first Landsat proved we could gather digitally encoded data from space and changed the way we look at Earth forever. Never-before-seen snapshots of land resources and the environment would be key for critical decision-making decades into the future. Landsat collects light. How intense that light is tells us about what's on the ground. You can think of intensity like shades of a different color. Landsat 9, the newest satellite to join the Landsat fleet, sees 16,384 shades. That's 4 times the depth of color of the previous Landsat, meaning we'll be able to see more detail in darker spots like coastal waters and dense forests. True color images are made by combining red, blue, and green light. Combined together, these visible bands of light make up all the colors in the rainbow, and all of Landsat's true color images. Landsat also captures light that we can't see. That type of light can reveal some incredible things when you look at a false color image, like the difference between types of plants, how healthy those plants are, healthy coral reefs, and even dead coral reefs, fire tracking, ocean pollution. The possibilities are nearly endless. There are 2 instruments aboard Landsat 9. OLI-2 is all about light. Once in orbit, OLI-2 collects sunlight reflected off Earth's surface. The light passes through a set of filters to separate out 9 specific wavelength bands, in visible and infrared frequencies. Each band provides different pieces of information about what is down on the surface. The second instrument aboard Landsat 9, called TIRS-2, collects thermal infrared wavelengths, or temperature signatures emitted by the Earth itself. "50 years ago, the U.S. Geological Survey had an idea. Satellites orbiting Earth that could help us monitor our natural resources. Today, the Landsat program is jointly managed by NASA and the USGS, providing an unparalleled record of Earth's changing landscapes for the benefit of all. 50 years of satellites. 50 years of life-changing data. One legacy continued with Landsat 9.
That is the Landsat for you. I'm always amazed by the possibilities that it is carrying with the satellite. This was the excellent video which I could find for you to explain the importance and amazing quality which Landsat has. So quickly let's have a look at the mission profile. So here you can see we have this mission profile. So first of all, this will be going to a sun synchronous orbit, which is a polar orbit of around 98 degrees altitude. The perigee will be 359 miles and apogee will be 368 miles. So you can say like 360 kilometers. circular orbit, and you can see that everything is as per the plan. But you can see after the main engine cutoff of the Centaur at 16 minutes, we have a Landsat 9 separation in 1 hour 20 minutes. So there is a long coast phase. So talking about the coast phase, why do we have this coast phase? So there are certain reasons why do we have it, because since it is going to a polar orbit, right? So it could take more time for the Earth to rotate below, for a ground station to be near the uh, satellite separation. That's why after such a long phase, around almost 1 hour 4 minutes, the Landsat 9 is separated. The reason could be we want the satellite to be separated, and the ground station is seeing that, because if there is a problem with the separation, then if the ground station is in contact, then it can have the data with it. If they can resolve whether it has separated or not, obviously that is one, all the data which it is collected at that point. And there are other satellites also being flown today. There are multiple CubeSats from different student colleges and universities. So that will also be deployed after 2 hours or so. And you know that the Centaur is a capable stage, and it can have a long period of coast and with the multiple burns. This is only the capability of the Centaur stage, so that's why it can do that. Yeah, that is one thing. And after everything, we will have this deorbit fourth main engine start and main engine cutoff, which will just deorbit, fall back into the Earth. So that is what we have for the timeline. Now let's have a look. Let's shift over to the live stream. I think that has started.
Sentinel-2 satellites.
And
Temperature measurements from Landsat 9 will be used to calculate how much water was used by each farm field. The Central Platte Natural Resources District, like many throughout the western United States, relies on Landsat data to manage irrigation and increase water efficiency. Landsat 9 will also improve monitoring of coastal waters.
okay, so
The
here we
increased
have the live
precision
stream,
of data
guys,
sent back from
and
Landsat
let's
9
take
will
your
allow
questions
better
now
dispersion
if you
of
have
light
any.
reflected from Earth, making it
I
easier to
see it is
identify
scheduled for
intervening
this.
stars.
Yeah, I'll wander down to the beach. Richard, please do, if you have the opportunity to see
Growing
the launch,
competition in
just
planning development
every
is
time just
higher
go
than
out there
expected.
and feel the launch, because
Landsat's
literally you will
communications
feel it when it
Landsat's long
launches.
history lets us look into the
So,
past to see
hi
the
Louis
effects
Smith.
of land
Yes,
use
thank you so
changes.
much. Good to see you back. Hope everything is going well. Kind of, you can
The
say that.
consequences of climate
Will I
change
do
can also
Shenzhou
be seen
13
from
live stream?
Landsat's
I'll do that
long-term data.
certainly.
Scientists have
If
used
I'm not,
Landsat to track shrinking glaciers
they're
for decades,
having some
and
problems.
Landsat 9 will continue that effort.
Okay,
As
otherwise,
glaciers in the Himalayas are
glad
a
to see
key
the
water source
covering
for
of the launch.
billions
I
of
don't know
people in
much
South
about this
Asia.
mission. What altitude
Due
could
to
I
global
just
warming,
advise there a
increased
coast
meltwater collects in
done?
large lakes at high
Amazed that an
altitudes
instrument
and
that's
poses a flooding
sensitive
risk
can
to the
survive the
Western
launch process.
villages.
Yes, that's what
Landsat data
engineers
is
are there
essential to
for.
monitor the growth of these
Okay,
lakes.
now let's have a look at this.
Because of their location, glaciers are not easy to study in person. But Landsat's view from space allows us to study glaciers all around the globe. Landsat 9's improvements will make it easier to see features on the glacier surface. With that, we can better track how fast the glacier is moving. Knowing the velocity of the ice now and how it has changed over the past decades helps us forecast likely contributions to rising sea levels in a changing climate. Landsat 9 joins Landsat 8 to continue the unbroken string of Landsat data. For 5 decades, we have relied on Landsat's high-caliber, science-quality observations to understand and protect our home planet. And while Landsat 9 begins sending back data, we are already planning for the next evolution in the Landsat program.
The oldest running program of.
Now that we've seen what Landsat 9 will do, let's take a closer look at the spacecraft itself. Landsat 9 is 15 feet tall, 10 feet deep, and 10 feet long. Once in orbit, it will deploy a 32-foot-long solar panel and 4-foot-long Earth shield. With fuel, it weighs almost 7,200 pounds. The satellite has 2 main instruments, Operational Land Imager 2, for reflective band data and thermal infrared sensor 2 for thermal infrared bands. It will capture 700 photos each day and travel nearly 17,000 miles per hour. All right, we have a very special guest joining us who you may recognize from the movie Kong, Skull Island. Actor Mark Evan Jackson, thank you so much for joining us, also known as Landsat Steve.
In that film, I was known as Landsat
Yes,
Steve.
and you have the jacket on, too.
I do. I have a bona fide screen-used prop, screen-used piece of wardrobe.
Love it. So in the movie, you played a Landsat researcher surveying a fictional Skull Island. Vandenberg looks spectacularly like that fictional Skull Island this morning.
Yes.
We might see Kong coming out of the distance.
We should all be very vigilant. Anything could happen.
So you actually got a chance to see the rocket up close yesterday. Tell us about that.
It's stunning. I mean, it's legitimately breathtaking and a really special opportunity to think about being so close to something that, you know, within a day is going to be headed for space, and within the fairing, something that's going to live on for, you know, many years, gathering data as an Earth observation satellite. The full culmination of what it means, you know, to be at this stage of the game ready to launch is so remarkable. The science and the engineering and the creativity and the curiosity and the ambition and collaboration that leads to this day is, I mean, it's legitimately inspiring.
How much did you know, if anything, about Landsat before you played the character Landsat Steve, and how does that compare to what you know about the program now?
I'm embarrassed to admit that I was completely unaware of Landsat as an entity prior to getting this role in the film, but immediately began looking into what it meant to be Landsat and to be a Landsat scientist. And Hollywood does a very good job of doing their research. Some of our hand props I've shown to some actual Landsat scientists, and they are very bewildered to go, like, a lot of this is right. Like, a lot of this is accurate. Now I'm fascinated by the goings-on at Landsat. Like, it's so remarkable to think about the nearly 50 years of continuous observation and data gathering, and also that all of Landsat's data is available and free to the public and to industry, and people are able to access it and use it to see how our planet is sadly changing.
Of course. And now you're going to be watching launch just feet from where we're sitting.
Yes.
Over here. Hopefully this marine layer will clear out enough so that we're starting to see the launch pad. It's a little better than it was a couple hours ago.
I feel very good about it. Yeah, I think things are heading in a good direction.
All right. Well, Mark Evan Jackson, thank you so much for joining us. We hope you enjoyed the launch today.
Thank you very much.
All right, let's go over to Daryl and Mick now for a check of the launch weather forecast. Daryl?
All right, thank you, Marie, and good to see that Landsat Steve's doing much better. Since we last saw him on Kong Skull Island, he was getting flattened.
Yeah, he looks a lot better than he did in that final scene. So
Sure does.
glad to have him here today.
Yeah, he was land flat Steve after that movie, so now he's back to his normal self. Good to see. Great interview. Thanks for that. The weather briefing just happened. We just got some news that is great. Of course, the 90% go is still on. Our launch weather officer, Addison Nichols, saying that essentially we are looking great, even though when you look outside, it doesn't look all that fantastic. Our progress bar showing that we are at the weather briefing, and we just had it. Take a look at the satellite. We can show you a couple things that are in play here. Two weather features along the central coast right to the left. There's a upper level low that's squeezing to the right, a monsoonal low. And so in between, we've got some calm winds and a thick marine layer. Those don't affect launch. So right at T0, we're 90% go. Very small concern for surface winds. And again, just a minor factor, Mick.
Yeah, absolutely, Daryl. These weather looks great here for us in Vandenberg today, so glad to see weather's cooperating with us.
Unfortunately, the 30th Space Launch Delta forecast deteriorates significantly tomorrow, which is the backup day, because as you see in this loop, that cold front will play bigger tomorrow than it does today. And in fact, it's only a 40% go, because ground winds will be gusting up to 24 knots. You can see in the upper left-hand part of your screen that upper level low. It will drop down and winds will
actually
increase.
Incredible.
And that will put us in a situation where we don't want to be, Mac.
Yeah, absolutely. Those
So
winds
they are launching Landsat, and now they are actually discussing the weather forecast with the data which they have gathered through other Landsat which is already in the orbit. So this is so cool.
See, there's some fog There's even some smoke from nearby fires, making a little bit of a haze, but we are go for launch. We'll send it back. Actually, we'll talk a little bit about LSP in a future segment, but for now, let's go back to Marie.
The best thing about rocket launches is that we don't need to worry about the visibility because everything is controlled by the computer and it does not need to have any cameras on it, right? At
And
least
as we
for now.
mentioned, this program dates back almost half a century. Here's an animation we're about to show you of the timeline of the Landsat program, starting with Landsat-1. It launched back in 1972, and it takes us all the way through Landsat-9, of course, launching today. The hashed lines for Landsat 7 through 9 indicate the uncertain lifespan of the satellites. Landsat 6 failed to reach orbit after launch. Still, it's hard to overstate the value of the Landsat archive of the past 49 years. One more history lesson before our next guest. Take a look at a photo we have from 1971 inside the Launch Control Center at Kennedy Space Center. There it is over on the Florida coast. This was when Apollo 15 was preparing to launch. And the man on the far right is Dr. James Fletcher. He was the NASA administrator at the time. And as administrator, he would go on to predict that if there were one space-age development that would save the world, it would be Landsat.
Exactly.
50 years ago, the U.S.
Was
Geological
right.
Survey had an idea. Satellites orbiting Earth that could help us monitor our natural resources. Today, the Landsat program is jointly managed by NASA and the USGS, providing an unparalleled record of Earth's changing landscapes for the benefit of all. 50 years of satellites. 50 years of life-changing data. One legacy continued with Landsat 9.
We have a special guest standing by now with NASA
Although,
Edge's
guys, you must be wondering that we have a fog here, but we have fog because there are no winds. So yes, that is good.
Native American to serve as the United States Secretary of the Interior and on the as in a cabinet level post, Deb Haaland. Secretary Haaland, thanks so much for joining the show this morning.
I'm thrilled to be here. Thanks for having me.
When we think of Landsat, Landsat's shown us a lot of interesting things, how we're impacted by drought, hurricanes, even man-induced activities like urban development and deforestation. How does this kind of data help the average person?
Well, I'll tell you what, those of us in the Department of the Interior and the government-wide, we're making policies every day to make sure that we can keep our environment safe and clean for generations to come. And hard data like this helps us incredibly. But also, look, we have opportunities to see those changes over time. The Landsat's been in existence for the last 50 years. The technology gets better and better each time. And so this is such a rich form of data that we can use that will help people's everyday lives. They may not know that, but there's folks working behind the scenes every single day to make sure that people can have what they need moving into the future.
Well, it's interesting because I was going to segue right into how this impacts policy, but you jumped there right away. So in your experience so far, have you worked with lawmakers to sort of chart some policies that would actually be helpful in regards to climate change?
Absolutely. And of course, we're in the thick of the climate crisis right now. We see that every day. Drought, wildfires, hurricanes. Hurricane Ida that devastated parts of the South and went all the way up to New England. Images like the ones that Landsat 9 will bring back to us will help us tremendously to guide us in how we are approaching climate change, working to make sure that we can make the best decisions possible so that folks have water into the future, that we can grow our food into the future. These are all things that will affect the daily lives of every single American, and quite frankly, these are pictures from around the world, not just the United States. So it's going to help folks all over the world to make those decisions, and it's unmistakable incredible hard data that we can use every day.
Absolutely. Thank you so much, Secretary Holland, for being on the show. Back to you, Daryl.
We are now L-20 minutes and counting until launch, and we've been monitoring the launch teams with our headsets. We're plugged in, and Mick, you just got some good news.
Yeah, we did. We got to hear from the launch team that everything is go. They're back on schedule. Things are working well, and we are green for our 11-12 launch opportunity this morning. So that's exciting that we're getting ready to launch Landsat 9.
That's great news. We've got a little moisture on the camera, as you can see there. There's a little mist in the air. There's some fog, and there's a marine layer, but none of it is expected to stop this opportunity today. Mick, want to talk about the launch time at 11:12 a.m. Pacific time. That actually moved 1 minute. What was the reason for that?
Yeah, Daryl, we moved the 1 minute to 11:12 this morning in order to accommodate a COLA, or what we call a collision on launch assessment. For the C-Train, the C-Train is made up of two satellites, Calypso and CloudSat, that LSP launched back in 2006. And we want to make sure that when we launch Landsat 9 this morning, we get it in that near-polar sun-synchronous orbit, but we don't want to hit our fellow satellites that are Earth-observing. So to avoid that, we made sure that Landsat 9 needed where to go. We moved the launch by 1 minute in order to avoid the CloudSat satellite.
Got to have room in space to get to space, and so we are looking good from that aspect as well. As we look at a shot here from the pad, you can see the steam that's coming off the rocket. Those are just vent valves, right, that are venting off excess liquid oxygen.
Yes, Daryl. Actually, as the team is finished up, we're in what we call topping mode. And as the liquid oxygen, liquid hydrogen boils off, that's what you see coming off there. And as we get ready to go into T-4,
there is no liquid hydrogen, guys. Okay, yeah, there is liquid hydrogen in the
flight pressures.
Now, as you look at that rocket, there's actually a special dedication on it. You can't see it, but we're going to show it to you in a second. There's a special dedication there, and the reason is it's because of this man, Thomas Heater II. Heater began his 45-year career in the launch business at General Dynamics and relocated here to Vandenberg as a flight test engineer in the mid-60s. He rose to director of Vandenberg launch operations, and during that time supported 200 Atlas, Titan, and Athena launches. Heater II passed away several years ago, and so ULA put this special dedication to him on the side of the Atlas V rocket, and you can see it there in memory of our colleague and friend, Tom Heater II. His family and friends gathered around the rocket as well and took a photo. And Mick, you had the privilege of working under Heater II, and may I just point out, between the U and the A, right there on the L, is Thomas Heater II's son, the third.
Yes, Daryl. Mr. Heater was a remarkable leader, humble person, and you know what? I had the privilege of working with him on many Atlas missions here at Vandenberg Space Force Base before I started with NASA. Mr. Heater was the director of launch operations at Space Launch Complex 3, but what I remember the most is he would always keep an eye on things going on at the pad, but he always took care of his people and looked out for things. And as you said, special note for us in Launch Services Program, we get to work with his son, who is today's launch director, who we will hear from later, and he's a remarkable person also. Well, great dedication to the Heater family.
Indeed, and we'll hear him report out as the last in the L-7 poll. We'll get to that in a bit. But first, I want to talk about LSP and their ability to bring together the rocket and the spacecraft.
Okay, so guys, everything is looking great right now, and if you are wondering that yes, the visibility is not great and we might not see some great footage out there for the rocket launch, but since the weather is foggy, that implies there is no ground winds, and that's why we are 90% go for the launch. And in rockets, we don't require visibility. Everything is controlled by computers, unlike any other vehicles, which actually require some sort of visibility. But here, that is not the case. And yeah, that's why we are 90% go for the launch, and tomorrow it's 40%. So let's hope we have a go for the launch today, and we launch it today. And guys, everything is looking great. We are green for the launch, and Landsat 9 is like the most amazing satellite, Earth observation satellite that I have ever seen, and NISAR is in the making, which is also one of the most amazing satellite, in fact the most advanced and the most costliest satellites of all, around $1 billion of Earth observing. It's in the making, but right now this is the great one. Hey, remember me? Yes, Arya, I do remember you. Everything is great right now, and let's have a look at the launch. And talking about those vents which are coming, it seems the vents are actually more this time, but that is not the case, because this is a foggy weather now, and when there is fog, so the vents look more enormous because of how the atmosphere is. It condenses more quickly, that's why.
To the rocket designer, and the spacecraft to the rocket. We provide long-term technical leadership and expertise from pre-mission planning to system verification and validation, all the way through launch. Whatever the vision or requirements, our team will be there, guiding our customers every step of the way on their journey through space. We are the common thread that connects the science world to the physical world by putting the necessary instruments in place. The thread that weaves NASA's industry-leading knowledge and support into the fabric of the commercial space market. We unite customers, capabilities, and culture to explore space through unparalleled launch services.
The animations
NASA's
are
Launch
great.
Services Program. We are Earth's bridge to space.
Cool.
It is L-minus 14 minutes and counting until liftoff. We've talked a lot about the history of Landsat, but we would be remiss if we did not point out the mother of Landsat, the woman who created and fought for it. Virginia Norwood was an MIT graduate and physicist working at Hughes Aircraft Company in the 1960s, and she knew NASA wanted a way to capture multispectral images from space. She set out to solve the problem, and through years of research, development, and testing, she created the multispectral scanner system that flew on the very first Landsat satellite. As a testament to her legacy, there is an entire group of women on Twitter who call themselves the Ladies of Landsat. They draw inspiration from Norwood as they highlight the work of underrepresented researchers, and we will hear from the co-founder of this group a little later after launch. Virginia Norwood could not be with us today, but we do have some of the Ladies of Landsat here at Vandenberg to see the launch up close, and we hope they enjoy it. Joining me now is Dr. Thomas Zurbuchen, Associate Administrator for NASA's Mission Directorate. Thomas, thanks for being here. It's starting to clear up. We can actually see the pad now. Tell us, how does Landsat tie into the entire Science Directorate portfolio?
Marie, what an amazing day. I'm just so excited. And of course, this is the first of 11 launches in Earth science in the next 2-3 years, just from NASA alone. Mm-hmm. And in many ways, the way I think about Landsat, it's really the foundation, the contextual data in which we look at all the Earth science we do, the research that we're doing, looking at our amazing planet. Because of the nearly 50-year time, the way I think about it is almost like a painting. Our research is the paint, the Landsat is the canvas. So it really belongs together very deeply.
Absolutely. And Landsat obviously looks down on Earth, surveying the entire planet. Does anything we learn from Landsat help us turn outward to explore further into the solar system?
Absolutely. You know, the work that we're doing in all of NASA, of course, expands beyond Earth science. We have missions that will go to the Trojans, a planetary mission, the James Webb Space Telescope launching later this year, and we use the very same technology that we're using for these analysis of the cosmos of other planets, looking at our planet. So yes, we learn from there to here, but very much we learn from the Earth science instruments to look at how we explore other planets.
Sure. I want to also ask you about this huge treasure trove of data available for researchers. It's available to the public. First, we have a quick video to explain that.
Landsat archives its 9 millionth scene.
The great one. Okay, watch it again.
Each scene is a satellite image from space, about 115 miles wide. Researchers and, well, just about anyone can download scenes from the Landsat archive managed by USGS. Landsat holds the title for the longest continuous space-based record of Earth in existence. That's 50 years of scenes like these, helping scientists and researchers understand how our planet is changing over time.
So we just saw a video there about Landsat having archived 9 million images and counting. We're adding 700 every day to that. Until the earlier 2000s, this data was not free. People had to pay per scene. Now that's completely free. It's available to anyone who wants it. Why is that so significant?
Well, it's absolutely essential to unleash the power of the data that we have. Of course, our partnership with USGS remains strong. They are our, if you want, translators of really the images to the application spaces in our world, whether it's agriculture, fisheries, and beyond. But by making the imagery public, what happens is that companies, non-for-profit or for-profit companies, can take those data and put their own data on top of it and actually add to the value of the Landsat data in ways that otherwise would not occur. So it's a huge stimulant on entrepreneurial thinking of the type that the U.S. is known for.
And beyond Landsat, we're looking forward to launch in 10 minutes or so. But real quickly, what else are you looking forward to this year for the Science Mission Directorate?
Wow, it's an amazing year. Frankly, there's hardly ever been one like this. Just 2-3 weeks from now, around mid-October, we're going to launch Lucy to the Trojans. They're out there at Jupiter distances, bodies of the solar system we've never observed. The James Webb Space Telescope in 2 missions, one looking at the Milan universe in X-rays, and then the first collision experiment of a spacecraft with a near-Earth object.
All right, Dr. Thomas Zurbuchen, thank you so much for joining us. Enjoy the launch.
We are actually having some pretty good launches coming up, the JWST and this Lucy mission, and one more Artemis if that happens.
We've been listening to the launch team and just got some great news from NASA launch manager Tim Dunn, who declared that Landsat 9 is now on internal power. That means things are looking really good.
Yeah, Tim Dunn completed his poll with the team, notified them that weather looks good, the range is good, spacecraft is on internal power, like you said, Daryl, and those are all good indications that we are go for launch at 11:12 this morning. So excited to hear about that. The next up, we will hear from United Launch Alliance launch conductor Scott Barney. He will perform at L-7, the ULA teams poll, where we will hear the team give their go, ready to enter terminal count. And as we mentioned earlier, Launch Director Tom Heater will give that final proceed to launch.
And, of course, a dedication going up on the rocket with his name on it. His son, as you mentioned, the launch director. We'll be listening for that poll, which is coming at L-7 minutes. If you look across the bottom of the screen, you can see we're at weather briefing. Coming up is polling, and we'll hit that at L-7 as we count down. 60 more seconds until that moment. As we look out at the rocket, we see that we've had a little bit of clearing. That doesn't affect the chance for launch. But, Mick, it's nice to see that there's a little more visibility, 4 miles visibility, which is exactly the distance between this rocket and our host desk where Marie is in the launch viewing area.
Yeah, I'm feeling a lot better seeing some of that fog clear off, that Marie will be able to actually see something from where she's located. With all the guests she has up there, that's exciting. Like we said, the weather is really cooperating with us this morning, and as this fog here in Vandenberg moves out, weather still remains go, and the United Space Force has assured us that we have a green all the way through launch.
And once they go green and once this thing launches, it will be the 2000th launch from Vandenberg Space Force Base, as well as the 300th Atlas. Let's listen in now as they conduct that poll.
L-7 minutes. Status check to proceed with terminal count. Atlas systems. Propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems. Propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go. Gas. Go. Electrical systems. Airborne. Go. Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. GCQ. Go. Operation support. Go. COM. Go. Umbilicals. Go. ECS. Go. Red line monitor. Go. Quality. Go. Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. Go. Range coordinator. Clear to proceed. Launch director. You have permission to launch.
And there you go, guys.
ALC, verify T0 is set for 1812 Zulu. Verified.
T minus 6 minutes.
1812 Zulu, that's UTC
Whoa, this
time,
is happening.
and we are go. And I got to tell you, it was nice to hear Tom Heater III give that go right there at the end.
Absolutely. I got goosebumps here, Daryl. Every time we get to this point in a launch, it is great to hear the team give their goes. And this is special for me, too, to dedicate this to Mr. Tom Heater II and hear Tom Heater give that proceed to launch. That is so, I can't even explain how I'm feeling right now. I'm so excited for Landsat 9 this morning. Looking forward to this launch.
His family and friends also here present to watch this with all of us. We are now counting down to the T-4 hold, where we're going to get those clocks synced up with the T clock and the L clock. This has kind of been a windy road to get to this point, though, Mick. This launch originally scheduled for September 16th. It moved to the 23rd. There were some issues with liquid nitrogen getting into the pad because of a COVID-19 induced issue with liquid oxygen back in Florida. So it created a shortage here. Moved past that. Also had a little issue with the spacecraft getting it up because of the winds. But Launch Services Program stuck with it, stayed the course, and got us to the launch day today.
Yeah, you know, I'm very proud of the team. NASA's Launch Services Program, our commercial partner, United Launch Alliance, the United States Space Force, they worked hard to get through this. It has been a windy road to get here, but you know, the team's dedicated. This is just part of the rocket business, and these guys have maintained their processes, followed through their procedures, and worked diligently to get us here today, Daryl. So I can't say enough about the teams that have continued to bring us here for Landsat's launch this morning.
Efric, I don't think so that would be the case, because when you will go there to...
T-minus 4 minutes and counting.
Okay. So...
3, 2, 1, mark.
So we just heard now the L clock and the T clock will sync up. We are now entering terminal count. At T-3, we will hear the team secure topping and verify that everything's at flight levels. Around 2 minutes and 50 seconds, we will hear that the flight termination system will go to internal power, making sure that all the safety protocols are on the rocket as we launch this morning. And around 2 minutes, we'll hear that the Atlas and Centaur vehicle go internal on battery power, which means is a clear signal that we will be launching on time this morning. And then at 1 minute, we will hear the United States Space Force give us a range go or green thumbs up, and we will then proceed into our T0 mark for Landsat 9 this morning.
As you can see there, the rocket against a dreary backdrop with a marine layer and a little bit of fog.
Guys.
It's 93% humidity here along the central coast of California.
That's why
it's about
vents are also looking much larger this time.
None of that is a factor. Over the past few days, we've also seen some smoke from a nearby wildfire at Sequoia National Forest. There you're looking right down the side of the booster, the Atlas V booster, and seeing that condensation coming off that super chilled skin of the rocket.
Yeah, I love that shot, that rocket cam shot. That'll be a great shot as we lift off this morning. And as you said, seeing that super chilled tank as it filled with liquid oxygen and liquid hydrogen on the Centaur tanks this morning, we're just excited about this. And we just heard from the team that they're going to flight levels on the tanks, and so that's a good sign that we are getting ready to close those vent valves and move into what we call step 3 for flight pressures.
Once that rocket lights, that orange fire will certainly change the light and change the mood of many of the folks who are watching this. Certainly on TV, you're going to see all of that. We've got all the cameras focused in, all the
Guys,
angles.
T-2 minutes until the launch. Everything is looking great. We are go for the launch, and we are... Okay.
So we just heard the call, Daryl, for vehicle internal. That's a good sign.
Okay, vehicle is
in the last poll here to verify everything is go.
Securing Centaur LH2.
Securing Centaur LO2.
There's where they're securing and shutting off the vent valves and the securing the vehicle.
Launch enabled. 137.
Guys, it's happening. Finally.
Armed.
After
Flight
so
termination
long.
system is armed. We are getting closer and closer to that T0 mark, Daryl.
Okay.
And there's a big moment at T-minus 45 seconds. What do we hear there?
We're going to hear the launch conductor, Scott Barney, verify from the last minute that everybody's ready to go, and we get a green to go for launch.
It's been a lot of work to get to this point. A lot of preparation. Let's listen in.
There, we just heard vent valves locked, and as you saw, Daryl, you pointed out earlier that steaming off the vehicle has now stopped. The vent valves are up.
Rock, report range status.
The range is green.
That is a great sign to hear range is green, Daryl, that we are good to go.
We are good to go, guys. T minus 50 seconds. Everything is looking
Coming up
great.
on that poll from launch conductor Scott Barney.
Right now, we will be seeing this onboard camera also. Everything is looking
40.
great.
Stable at step 3.
And let's listen in now. I am so excited. Can't tell you. I've been waiting for so long this to happen. Finally, T minus 30 seconds.
25.
Status check. Go Atlas. Go Centaur. Go Landsat 9.
T minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11.
9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of an Atlas V rocket and Landsat 9, continuing the legacy of an irreplaceable 50-year record on our ever-changing planet.
And it's gone.
Control system response looks good. RD-180 engine operating parameters continue to look good. Vehicle has begun the pitch over maneuver. Body rates look good.
Everything is looking
That
great
pitch over
right
maneuver,
now.
heading it to the south towards Southern California and down to Mexico.
Now passing 40 seconds into flight. Engine operating parameters continue to look good. Pump speeds and injector pressures all within expected ranges.
Everything is looking great.
There's
It
a
looked
shot from our tracker
like
cam above.
we might not see the liftoff, but everything is looking great right now.
Body rate responses continue to look good.
And it has pitched over, so that's why the flames
3
are
minutes
tilted.
remaining in the boost phase of flight. Pump speeds and injector pressures on the RD-180 continue to look good.
You have the velocity and the altitude there. You can see that. How
Body
the
rates
things are
continuing
looking.
to look good.
Everything is looking great right now.
And at 1 minute 20 seconds into flight, Atlas is now supersonic, vehicle passing Mach 1.
Now
And vehicle is now passing max Q, maximum dynamic pressure.
we will see this flame, the plume being expanded right now, and it has cleared the clouds and fog, so image is looking
Now
great.
throttling down slightly as expected. Engine response looks good.
That throttle down reduces the stress on the 19-story tall
At
vehicle.
1 minute 50 seconds into flight, vehicle is now 10.7, correction, 13 miles in altitude, 7.9 miles downrange distance, traveling at 1,500 miles per hour.
And there you go, the beautiful plume expansion coming up now, guys.
Now just under 2 minutes remaining in the boost phase of flight.
This is great. See that beautiful Earth from behind. Wow.
At 2 minutes 18 seconds, the Atlas V vehicle now weighs just 1/2 of its liftoff weight. And vehicle's gone to closed loop guidance. Body rates indicating a slight adjustment can be expected for this phase of flight.
There's a beautiful shot right there, looking back towards the planet.
Just
and see the plume from the RD-180.
I think that's the
And the
glaciers, I
reaction
guess.
control system on the Centaur is now pressurizing to flight levels. System pressure response looks good.
So the reaction
2
control
minutes,
system
50
on
seconds in
Centaur,
flight.
they're prepping it.
RD-180 engine operating parameters continue to look good throughout boost phase. Body rates remain stable.
Coming up in 60 seconds, the booster engines will cut off.
Approximately
Again,
1 minute
let me
remaining
repeat.
now until booster engine cutoff.
Guys, this is going to the polar orbit, so that's why you will not see a proper Earth rotation, but yes, you will see.
Our tracker shot getting a great.
And now 3 minutes, 15 seconds into flight. Atlas is 48 miles in altitude, 70 miles downrange distance, traveling at 5,600 miles per hour.
Wow.
Great
see
shot as
these
it goes out over the southern Pacific.
plumes coming out of the rocket.
Pump
Just
speeds and injector
great.
pressures on RD-180 continue to look good throughout boost phase.
Wow. We should be having the MECO now.
And the Atlas V is now throttling to maintain a constant 5G acceleration limit. Engine response looks good.
Speed currently 7,700 miles per hour.
Has begun boost phase chill down.
Oh man, this is
Now throttling to maintain a constant 4.6 G acceleration limit in
this
preparation for
camera.
beat go.
This is where the booster engine cuts off and then separates.
And we have beat go
And
booster engine cutoff standing by
whoa,
for stage Sept.
that was such a cool shot.
And we have good indication of Atlas Centaur separation. We have pre-start on the RL-10, standing by for ignition.
And there you see the separation.
Large happening right now, and we have the ignition.
And full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
Beautiful shot of the booster falling away as you're looking down.
Good indication of payload fairing jettison.
You should see the payload fairings. Sometimes they come around the side.
12 minutes, 11 seconds.
And there you go. We can see the payload fairing.
Performance continues to look good in the early part of this first burn. Now passing 4 minutes, 47 seconds into flight.
So we're in a good point, Mick. Flight is looking good. We're going to monitor the situation here. But what a beautiful launch. What a beautiful flight so far.
5 minutes.
But there's still a lot of work to do.
Yeah, absolutely. A lot of work to go on, but beautiful shot there of the RL-10 engine in space, sending Landsat 9 onto its orbit. A great launch this morning. So excited for this.
We're getting some of that orbital sunrise on the engine bell there, and that's just a neat look as you look back at our planet. All right, Marie, we'll keep track of things in here, but for the meantime, we'll send it back out to you on the hill.
All right, thanks, guys. We did get lucky enough for that marine layer to clear so we could see liftoff from here at the gravel pit. Earlier, I had the opportunity to speak with NASA Administrator Bill Nelson about today's launch. Take a listen. NASA Administrator Bill Nelson, thank you so much for joining us. You have described climate change as an all-hands-on-deck global challenge that requires action now. Tell us, how does the Landsat program help leaders take action now to address climate change?
We best get on the business of doing it right now. And what Landsat does, it is the longest continuous global satellite record of the Earth's surface. And these satellites have documented Earth's changing landscape. It helps farmers, scientists, understand and manage land resources, and all of that is needed to sustain human life. Such things as food and water and forest.
That's what has happened here.
And of course, Landsat's long-term record of our home planet allows us to track the changes and the impacts of climate change.
And President Biden's fiscal year 2022 budget requests $24.8 billion for NASA. That's a 6% increase from last year, and also the strongest budget NASA has ever had for science. How do you quantify the value of NASA's science missions?
It is a very strong budget request. The value is immense. And when you're talking about data like this, it's hard data that arms decision makers with the tools they need to make tough decisions about our future. It's exploration on other planets, helping to answer the age-old questions. How did we get there? Are we alone? It's the inspiration of the next generation. That is what this science budget is all about.
And besides Landsat, in what other ways is NASA making it a priority to understand and respond to climate change?
Well, we are doubling our efforts to lead when it comes to climate science. Earlier this summer, we announced a new Earth Systems Observatory. It's going to be 5 great observatories that will look at the land, the oceans, the ice, and the atmosphere, and combine a 3D composite of what is happening very precisely to our atmosphere. That, combined with all of our other existing assets, such as the Landsats, it's going to develop the ability for us to really measure what is happening. And also, we're continuing to develop resources for sustainable aviation. That is less pollution in the air from aircraft, and it will keep industry in U.S. competitive and drive fuel efficiency that helps the environment.
Administrator Bill Nelson, thank you so much for your time.
Thanks a lot. Have a great day.
All right, there is a live view on your screen now of Landsat on its way into orbit. Turning now to one of the many practical applications of Landsat, the U.S. Department of Agriculture uses it to track annual yield of every crop grown in the United States. Disaster managers can see impacts from floods and other natural disasters. Resource managers can use the data to direct crop rotation and monitor water use. Take a look.
America has always been a fertile land. Grasslands and forests and farms from sea
Okay,
to
so it was a great launch, guys. Everything looked great. The best thing about this launch was that stage separation and that infrared camera which was there, and we were able to see that plume just going away from the rocket. The plume is actually very big. It's like miles, a few miles long, diameter or radius, whatever you want to say. It looks smaller, but they spread at a very to a very large distance. So that is a thing. And yes, they did cut out from the rocket stream to this interview, but that's how it is when it comes to government launches. So I think we'll have to go with it. NASA still haven't learned. Okay, not letting Google near my trigger happy.
The data helps estimate crop yields, which helps farmers and traders set prices for the harvest. Thanks to Landsat's detailed view, the USDA tabulates stats crop by crop, county by county, and state by state. At the end of each year, the data set is released to the public, and it is a beautiful sight. The patchwork of corn in yellow and soybeans in green in the Midwest. The diversity of crops in California's Central Valley. The clusters of citrus in Florida and California and Texas. We can see changes in farming through the years. The easiest to see is crop rotation in the Midwest, cycling between corn and soybeans. In northern North Dakota, there is a shift from barley and wheat to soybeans and canola. And we see an increase in cotton fields, shown in red, in Texas and Oklahoma. Thanks to the free and open access to Landsat data, the U.S. Department of Agriculture is providing our farmers with accurate data and helping maintain our nation's food supply.
All right, we want to bring in a special guest now from Northrop Grumman, the company that actually built the Landsat 9 satellite. Frank DeMoro, you are the Vice President of Tactical Space Systems for Northrop Grumman. And I understand this was your first launch out here at Vandenberg. How was it?
It was really special to see that rocket lift off.
Yeah, well, I tell you, we got a little lucky. It's also my first one, so we shared that together. But the last couple of days, the marine layer has been so thick, it's been very hit or miss, our view from here to the launch pad 4 miles away. So we lucked out. I'm glad you got to see it lift off.
Yeah, it was a special time, special time.
So this is Landsat 9 is the 4th satellite that Northrop Grumman has built for NASA. Tell us about the process. What goes into building a Landsat satellite and integrating it with the instruments?
This is the last of Atlas. No, we currently have many launches of Atlas left, but the Delta IV Heavy is going away, and once the Atlas V also has now has an expiration date, but Vulcan is coming up, so let's see what happens.
Transfer systems are all in place to be able to accommodate the instruments. And then once we put that all together and put the instruments on the spacecraft, it goes through a rigorous test process. So that when we deliver it here and it gets launched like you saw today, it's ready to go.
There are so many things, as you know, that have to go right for a rocket launch to happen. And certainly the workers that you described in Gilbert, Arizona are a big part of that. You know, all of the meticulous work I'm sure they had to do to get to this point. Can you talk a little bit about that team, you know, what it's been like working through the COVID pandemic and any impact that's had at all?
Well, it's a really special team, and they're so dedicated to this mission. The fact that this is our 4th Landsat mission, partnering with NASA all these years in this type of mission is really special. And the team understands that. And as they've worked through the past year and a half, they've just continued to work through the COVID period, being dedicated to this mission, knowing what it really means to NASA, what it really means to the nation to get this data down to the ground. So they've persevered, they've worked really hard, and I'm really so proud of them. Mainly, that's the main thing I'm most excited for today, is what the team gets to see.
Well, congratulations to you and the Northrop Grumman team.
Well, thank you very much. Appreciate it.
You're welcome. Thanks for being here. All right, we are now at launch plus 14 minutes, 37 seconds and counting. We expect Landsat 9 to reach orbit, its intended orbit, in just a few minutes, and here's some things to know about that. It will circle the Earth at an altitude of 438 miles. It will travel at 16,760 miles per hour, or 4.6 miles per second. Each orbit around the Earth will take 99 minutes, so Landsat 9 will complete 14 orbits per day. Landsat 9 will take more than 700 pictures of Earth every day.
Cool.
All right, and as I mentioned, we are approaching that orbit milestone, so let's get over to Daryl and Mick to take us through the next few minutes. Guys?
That's right, Marie. We are just seconds away from main engine cutoff. Centaur has been burning now for several minutes. It's really close. When this happens, we're going to be in an orbit that's a little bit higher. You just heard we're just about a minute out.
Yeah, so what's happening is we have this first burn, and we're trying to get a slightly lofted orbit this morning into that near-polar sun-synchronous orbit, Daryl, so that we can get Landsat 9 up there. What will happen is main engine cutoff will occur, and then we will coast for several minutes to get Landsat 9 into the orbit it needs to be, and then we will get spacecraft separation at L plus 1 hour and 20 minutes.
Hard to believe. We're just a few seconds away from main engine cutoff, but hard to believe this spacecraft and this rocket have gone almost completely around the planet. Currently coming up through eastern Africa, over Turkey. We're just seconds away. Let's listen in to the call for main engine cutoff.
Okay. Yeah, the engine cutoff.
And we have MECO, main engine cutoff.
There you go. We have
body rates look good. The vehicle is now recovering from the shutdown transients.
And there you go, Daryl. We heard from United Launch Alliance commentator Patrick Moore, who's done a fantastic job since liftoff of filling us in on all the activities that have been going on, and we just got confirmation of main engine cutoff. So Landsat 9 and the Centaur will coast for a little bit, and then we're about an hour and 3 minutes from Landsat 9 separation.
Yeah, it'll coast for a lot of it, right? Because as you can see in the bottom of the screen, we have removed our progress bar with the milestones and now have a new progress bar, which will show you the time to spacecraft separation, which you can currently see is set at an hour and 3 minutes. We'll be monitoring everything here, but once again, we'll send it back out to the hill with Marie.
Okay.
All right, thanks, guys. Joining me now is Landsat 9 project scientist Jeff Masick. Jeff, thanks for being here.
I
how's
guess,
the launch?
guys, I won't be able to stream for this long, but the major milestone of achieving the orbit has already been achieved. So that's it, I guess. But let's have a look at our Twitter feed and see if there is any update or so. If you have any questions, you can surely ask me. Although the stream was kind of good, but ultimately it's NASA who is doing the stream, so we might not be able to, get that SpaceX feeling on it. So that's it.
More specifically about Landsat 9's two main instruments, the operational.
Let's hear the instruments first.
Infrared sensor too, a little bit of a mouthful, but we have a quick video about those, and then I want to ask you about them.
Sure.
There are two instruments aboard Landsat 9. OLI-2 is all about light. Once in orbit, OLI-2 collects sunlight reflected off Earth's surface. The light passes through a set of filters to separate out 9 specific wavelength bands, in visible and infrared frequencies. Each band provides different pieces of information about what is down on the surface. The second instrument aboard Landsat 9, called TIRS-2, collects thermal infrared wavelengths, or temperature signatures emitted by the Earth itself.
So that was a really quick breakdown. If you're a layperson like me, you have to watch that several times to absorb the information. Can you help us understand how those two instruments take measurements and work together and then send it back to Earth?
Sure. So as the video said, we have two instruments. One is looks at the shorter wavelengths, and so it basically looks at light that comes from the sun and is reflected back off the Earth to the OLE-2 instrument. The other instrument, TIRS-2, looks at the longer wavelengths, which are sensitive to surface temperature. And basically by combining the data from all the different spectral bands, you can fingerprint materials on the Earth. So you can tell what's vegetation, what's soil, what type of soil, and that's really what the scientists use, the analysis that they do.
All right. And I also want to ask you specifically about the different kinds of light that Landsat collects. We have another quick video to explain that.
True color images are made by combining red, blue, and green light. Combined together, these visible bands of light make up all the colors in the rainbow, and all of Landsat's true color images. Landsat also captures light that we can't see. That type of light can reveal some incredible things when you look at a false color image, like the difference between types of plants, how healthy those plants are, healthy coral reefs, and even dead coral reefs, fire tracking, ocean pollution. The possibilities are nearly endless.
Okay, so in that clip we heard about visible light versus non-visible light. I didn't even know non-visible light was a thing. True color versus false color. Again, didn't know there was even such a term as false color. So why do those things matter when you're interpreting data?
Right. So we really only can see 3 channels of light with our eyes at once. And so we have 11 channels on Landsat that we can put into any of those red, green, or blue layers to actually inspect. So a false color image is simply one where we take one of the infrared wavelengths that we normally can't see with our eyes and we turn it into a red, green, or blue channel on an image to look at. In fact, when people are actually analyzing their Landsat data, they may look at all 11 channels at once using something like an artificial intelligence algorithm on a computer. So actually looking at the image while it's beautiful isn't always necessary for getting the information out.
All right, Jeff Masick, Landsat 9 project scientist. Thank you so much for joining us.
So during the ML or AI application, you actually don't want those extra information. We always try to filter those information to the outlined, level, which means we only have the outlines. We don't even need the colors sometimes. So that is the thing when we are using ML and AI. But right now, guys, everything is looking great. We had a great liftoff. Everything was good. So now just have a look at good now. We can have at our Twitter feed. We will see this. We have already seen this. I don't think so. It would be beneficial for us to wait till 1 hour or something like that. It's always a thing, where we can have some interesting data out of. That's during the launch. That has already happened. So and now the man has spoken up. It's always looked that way to me, but sometimes is it me or are the Atlas 5 onboard camera but being broadcasted at 4:3? Okay. Have to wait and see. We'll answer that. Sorry, Bruno will answer it, so we'll get an idea out of it. But everything, today's launch was epic. I must say that. I've done around 400 launches over my career. Everyone is a killing one as the first. Yes, that is a thing. Okay, now it would be a good time to have a look at the mission. So if you can see that the Landsat separation will happen in 1 hour 20 minutes, but there will be a second engine start and cutoff at around 1 hour 50 minutes, and then a third engine start and third engine cutoff at 2 hour 11 minutes. and then the CubeSats will deploy at around 2 hour 14 minutes. So it's not only the Landsat flowing to orbit today, we have multiple CubeSats also, the universities made by students and all those things, so to have some data out of it. These are CubeSats, they will also be deployed, and then finally the Centaur will deorbit itself. So is a thing. Okay, so between MECO and RL-10, what's the problem there? Can you enlighten? Very unique mission. At Centaur 1. At first, the 4 CubeSats to different orbit, then deorbit, burn to ocean impact. So that summarizes the mission. Cool. And yes, Russian space is also getting heated up. MS-19 is about to be launched. Preparation of a manned spacecraft continues at Baikonur Cosmodrome at October 5 is its launch date. And why is it very much interesting? Because the crew for MS-19 is like us, citizens of normal Russia, you can say, because they are the actors and the directors are going to International Space Station to film a movie. Yes, that is happening. That's what makes an MS-19 a very interesting mission, because they will actually be filming the movies on ISS. That would be great. I would love to see that movie, because we have already seen how great their animations are without even going to space. Now, once they have the data from the actual space, I am just, whoa, it would be very great to see how they will manage that. So MS-19 and the crew of the MS-19 are uh, actually the actress. One is the actress, one is actual pilot, and one is the director. So yes, that is. Other than that, what is the? Yes, in the Starship, we are getting very much close to the liftoff for the Starship, also for the orbital launch attempt. Hopefully, in October, we will be seeing that happening also. So October is a month which we should be having multiple launches, and that too multiple exciting launches. Uh, this beautiful shot was the most epic shot. This plume which you were able to see, flickering from the rocket when it shuts down, that happens, was the most beautiful shot for this. I guess that's it. I don't. So we should be having. Yes, Chinese today launched 2 rockets, which was great. They have done this in past also. USA also has done this in past, wherein they launched 2 different rockets on a single day, but that was from different agencies, not from the single agency. So Chinese is like launching. Chinese space program is like boosting up right now. Great for humanity. And I guess that is pretty much about it. Don't think so. We should be having anything else here. S19 is great. Yep, that's it. Okay, guys, I think that's it for today. If you have any questions, you can ask me. Guess I'm a bit late. Yes, Wildflower, you are indeed very much late. And John Wilson. Tom Cruise is also looking at the ship. Indeed, he is. And right now, he actually signed a deal with Crew Dragon, the SpaceX basically, to fly him on board the Crew Dragon to ISS. But um I guess there is some glitch, or sorry, hitch on that contract, but the space race to film a documentary in space or a movie in space has been won by Russia, so they will be filming first. Yes, Tom Cruise has signed it. Have to wait and how things would look like. He signed it for Mission Impossible 6, I guess, right? All Mission Impossible movies from Tom Cruise are great. Thank you so much for the awesome coverage, and thank you so much, guys, for tuning in. It was a great experience always. to see you and interact with you guys. It was for so long that we weren't able to interact, and finally we were able to finally interact and have a good look at the launch. And I'll try my best to cover as much launches as possible. You might not see the videos coming. Maybe I will just post the launch videos after the launch has happened, if that is what you want. But other than that, I'll try to cover as much as launches as possible. But it's a certain phase in my life right now which is going on. Today was a happy day, I must say that I got to stream the launches. And if you want, guys, you can support me by joining this channel by clicking on the join button, and you should be having these tiers in which you will get various access, these emojis, as well as early access to new videos, member only live chats, and other Discord level access. The Discord is also there. You can join that Discord channel also, and if you are comfortable in becoming a member, you can do that, or you can just become our Patreon. It would also work, right? There you go. Whatever suits your demand, you can do that. I guess that's it. Thank you all for joining in. It was a great talking with you all, guys. Patreon link is down in the description. If you want, you can do that. It really helps me to keep these streams going. And I guess that's it. I don't feel like going, but I guess I have to go because I need to study tomorrow. Again, I have one interviews lined up. Busy days, busy life right now, so yeah. Okay, so the next launch coming up, let's just discuss that also. What is the next launch? I guess don't have any other launch lined up in September. We do have some Chinese launches, but again, the Chinese launches don't have any stream. But we have one interesting launch from the JAXA, which is going to happen on 1st October. So I'll try my best to stream that. If I don't have any exams or interview lined up on that day, I'll surely stream that. And then on 5th October, Soyuz DNS 18 on 12th, and Shenzhou 13 on 13th of October, which is a great mission coming up, and Lucy, of course. So we have interesting missions lined up in October. We'll see those things. And yes, guys, thank you so much for tuning in. It was a great experience finally streaming, and I hope I can catch you up again on 1st October. Until then, this is Priyanshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye.